Bismillah ar-Rahman ar-Rahim. In this lecture, we are going to speak about the related rates. Related rates, as it is stated, it is just a relation between two quantities in one function, and the changing in one function will affect the change in the other function. Sometimes it's just indirect, or the two quantities are functions of time. So we can say in general that in related rates problem, the idea is to compute the rate of change of one quantity terms of the rate of change of the another quantity. So we have two quantities. We are expressing one of the quantities as a function of the other change of rate for the second one. And to solve this kind of problems, we can go with strategy or some steps to make it easier to understand and solve the problem. For the solving this, we can go with these steps carefully. The first step, we need to read the problem carefully. We have to specify which quantity we are looking for and which quantity is given in the problem. Second step, draw a diagram if possible, because diagram usually make the problem easier to understand. Then step number 3, introduce notation. Give variable names for each quantity or side of the figure. Assign symbols to all quantities that are functions of time. This is the main thing. Express the given information and the required rate in terms of derivatives. Usually in such problems, you are given that the quantity is changing with time or the fast, measure the fast of changing or something like this. These are derivative of time, usually. Write an equation that relates the various quantities. We need to write the equation or the function. Number 6, we are using the chain rule to differentiate both sides of the equation with respect to time. So we need to write the function or the equation, then we differentiate the left-hand side, right-hand side with respect to t, the time. Step number 7, substitute the given information into the resulting equation and solve for the unknown rate. To apply these steps, let's have some examples. The first example says that if V is the volume of a cube with edge length x, and the cube expands as time passes. So we need to find dV by dt in terms of dx by dt. So in this question, say that the volume of a cube. So in the first step, I have to write the formula for the volume. I have a cube with size x. And we know that the volume of the cube is given by x to the power 3. It's the volume of the cube. And the question said that, and the cube expands as the time passes, means the volume is increasing. And by default, if the volume is increasing, means that the size of the cube also are increasing. So both of them are functions of time. Now I need to differentiate this equation with respect to t. So I say dv by dt is equal to. Now the right-hand side is a function of x. It is x to the power 3. But indirectly, it is a function of t because it is expands also as time passes. So x is also a function of t, which means that if we differentiate with respect to time, I will differentiate with respect to x first. That will be 3x squared multiplied by the derivative of the x with respect to t. This is the related rate. It is dv by dt equal to 3x squared, and then differentiate the given variable x with respect to time. Or in other words, we can say that dv by dx since I don't have time explicitly, I can do small trick about this one. This can be written as dv by dt multiplied by, or I'm sorry, this should be dt. It can be written as dv by dx multiplied by dx over dt. So it's like we are multiplying two fractions, so if you cancel this one with this one, I will have dv by dt. It means that in the first step, I need to differentiate the function with respect to x, then multiply the derivative of the variable x with respect to t. So this is the idea of a related rate. We are expressing the one quantity as a term of the change of rate of the second quantity, which is dx by dt. In the second part, say that if the length of the edge of a cube is increasing at a rate of 4 centimeter per second. Again, read it again. The length of the edge is increasing at a rate of, so this is dx by dt was given there. This is dx by dt. So we can say for b, we are given dx by dt equal to 4 meter per second. And we need how fast is the volume of the cube increasing when the edge is equal to 15 centimeters. This is x. So we are given dx by dt equal to 4 and x equal to 15 centimeters. So we need to find how fast is the volume. So I need to find dv by dt. I need to find this quantity. So all what I need, I'm going to substitute dv by dt is equal to 3x squared. So it is 3 multiplied by 15 squared multiplied by dx by dt, which is equal to 4. So this is 3 multiplied by 225 multiplied by 4. That will be about 300. This is 775 times 4. I will have this 675 multiplied by 4. So this will be, this is 0. 4 will be 30. Okay, so this 2430. So this is 2000. 0 and 3 there. So it is 2700. And the unit for this one is given by, because we squared this, I will have centimeter squared, and this is centimeter per second. So the unit will be centimeter cube per second. So this is the fast of increasing in the volume of the cube when we have that rate in the edge and when x equal to 15 centimeter. Another example. Suppose that we are given this, which is, let's say that the radius of a sphere is increasing at a rate of 4 millimeter per second. So again, we are given this radius of a sphere is increasing at a rate. Rate means a derivative. So in this one, we are given dr by dt equal to 4 millimeter per second. And the question says that how fast is the volume is increasing. So I have a sphere. Sphere means like a ball. And I need to find how fast is the volume is increasing. So in the first step, I have to write the equation or the formula for the volume. Volume of the sphere is given by 4 over 3 r to power 3 or by r3. Okay, just in this order, by r to power 3. This v equal to 4 over 3 by r to power 3. And we need to find dv by dt. Is the meaning of how fast is the volume is increasing. It means that I need to find change of rate of the volume. dv by dt is not given, which means that I have to differentiate this equation or formula. I will say dv by dt is equal to, because I have formula as a function of r, not time, but r is a function of t. So I can write it as dv by dr multiplied by dr by dt. Again, this is common, and that's why we are just writing in this way. This is just applying the chain rule. It is dv by dt is equal to the derivative of the function with respect to r multiplied by the derivative of r with respect to t. Now I need to differentiate this one with respect to r. So I will have 4 over 3 multiplied by the derivative of r with respect, or this function with respect to r. We differentiate this part, which is r to power 3. That will give me 3 r to power 2. This is only the first part, multiplied by dr by dt. Now we can substitute everything in this equation. We are given if the diameter equal to 80. This means because diameter equal to 2r, so r will be 40. So dv by dt is equal to, I can cancel this 3 with 3, it will be 4 by 40 square multiplied by by 4. So we got this.